Hello, everyone. Good morning, good afternoon, good evening, because I know we have people from all over. Thank you very much for joining us today for DataScience GO Connect. This is the first time this event is held like this, and I have the honor of being the first speaker, and I'm very humbled and incredibly happy about it. So just to tell you how this is going to work today, I'm going to give a 30-minute talk about the road to data science. Mostly it's going to be about the way I messed up while learning data science, so you don't have to. After those 30 minutes, we will have a Q&A session where you can all join us. We can talk for a while. We can discuss about what's going on. We will have a chance to talk live. We'll tell more on that later. And after the Q&A sessions, you'll be able to do one-on-one networking sessions, so you get to meet all the wonderful people that have joined us today. Very important, just in case, if you want to share anything that we talk about here today in social media, use the hashtag DSGO Connect. I will share it to you in a bit during the presentation. If you have any questions, feel free to put them in the chat at any point. And well, let's get started. And if you need anything, again, just tell us during the chat. And I'm about to show, give me just 1 second. And I think it's this one. And here we go. No, this is not it. And here we go. So now you can see my screen. Great. So the road to data science, how to take a smoother road from here, from where you are right now, to there, to being a data scientist. First of all, as I told you before, if you want to share anything on social media, use the hashtag DSGO Connect. Under here are all my hashtags. You can tag me, you can look for me, feel free to connect with me on LinkedIn or on Twitter, anything you want. And if you tag me, I will answer. So DSGO Connect for the rest of the day. The big question that I want to answer today is, can you or anyone become a data scientist without any previous background? But we'll answer this question throughout today's talk, and we'll probably have an answer by the end. So first, a little bit about me. My name's Jack Rafer. I'm from Costa Rica. Originally, I'm a psychologist, believe it or not even what you would call scientific psychology originally, because I studied clinical psychology, then I moved on to psychometrics, then to behavioral economics, which is sort of everything in the same sphere. And then a few years back, I just said, you know what, it's time to change. The world is changing. I need to change. Then that's when I got interested in data science and eventually learned about it and started working in it. Nowadays, I work in a company called Ana Intelligence. It is a company I helped found, and we do people analytics in a very particular sort of way. We don't just work with, for example, is this person going to buy, how to get more engagement, but more on the personality, how do we get people to be better? But we'll talk more about that a little bit later. So before anything else, why data science? Why do we want to get into the data science business? Well, there's 4 top reasons, at least for me. First of all, they call it the sexiest job of the 21st century. The truth is, data science, data analytics, everything that has to do with learning how to work with data and get information and insights out of data, building great applications from data, is growing very quickly, probably the biggest growing job market in the world. And of course, we live, there's a reason for this, is that we live in a world of data. Data has literally grown exponentially for the last 20, 30 years. Most of you probably don't remember this, some of you might. 40 megabyte hard disk was about the size of a brick about 30 years ago. Now, something the size of a brick has exabytes of information, and there's more and more and more data every day. We are practically digitizing everything in the world. We have more data right now than at any point, and about a year from now, we'll have at least twice of that, if not more. At the same time, the computational power is growing exponentially. There was a little bit of a winter a few years back where it wasn't growing as fast as it was before, but now with the advent of quantum computer, I'm sure it's going to pick up again and go even faster. So computational power is just exploding, and now you can do on your cell phone things that we couldn't even do with a whole computer 20, 30 years ago. And finally, decision-making machines, everything that's moving from neural networks to artificial intelligence, where machines can make decisions with autonomy by themselves. This is helping getting a lot of, making us more productive, making the world more productive, and making a lot of decisions faster and a lot better. Just to give you a quick example of this, once we got machine learning involved in reading things like X-rays, then we can get our specialists working less time in having to deal with patients that have absolutely nothing, and we can help them focus their time on patients that actually need their help. That is the big advantage of machine learning, and that's just one of hundreds and thousands of examples that we have right now. So I wanted to tell you a little bit about my road to data science very briefly, meaning how did I get from not knowing anything about data, or how did I get into it? Well, first of all, this is my first computer. You probably don't recognize it. That's called a Texas Instrument computer. I know nowadays, I think they make mostly, well, most people know their calculators, but they make other interesting stuff as well. That was the kind of computer where you could only program in something simple called BASIC. It was very clunky. It was very wordy and very complicated. Well, not complicated, but it took a lot of lines of code to do things that were very, very simple. The worst part is that if you wanted to load a program or you wanted to save a program, you had to do it on a cassette tape. Yeah, one of those things that go round and round and round. So, for example, for 1 kilobyte program, you probably have to wait about 10 to 15 minutes to either load or to save. This happened when I was about 10 to 11 years old, and then a big void. For many, 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 many years, apart from being a user of technology, I always liked technology. I was probably the unofficial IT guy for my whole family. But at the end of the day, I never got into studying anything else that had to do with technology or data or anything of the sort. Then, a few years back, I said, hey, data science sounds like a cool thing. So I took a course, I joined the course, and then I started learning programming in R. But things got difficult very quickly, and I sort of quit. I said, again, I have nothing against R. We'll talk about that later. But things got difficult, and I just stopped. I said, this is not for me right now. So there was a little bit of a small void, about 3 years. And then finally, I got into learning data science. And my first big mistake was, of course, data science is exciting. It sounds amazing. And I definitely wanted to get into the most exciting part of it as quickly as possible, which was machine learning. And I rushed through programming, and I rushed through to machine learning algorithms to get to the cool part. And that left me with a lot of gaps. So what would I do differently? First of all, what happened between the first time that I decided to study data science to the second? I discovered why. I actually put into words, why is it that I wanted to learn data science? For me, it was simple. Most of the things that are built today, and the machine learning algorithms that are affecting our lives have to do with advertising, have to do with pushing us to buy stuff, pushing us to engage with content that maybe we don't really want to engage in. It's not pushing us to be better humans, it's pushing us to be better consumers. At least that's my take on it. And for me, I wanted to get into data science so I could start building on the other side and doing machine learning and doing data science to help people, to become better humans, to increase their emotional intelligence. So this is the one thing that I would tell you to take a little bit of a break, stop for a second and think about this. Why do you want to become a data scientist? What is it that moves you? What's the end game? What do you want to achieve by becoming a data scientist? What is it in the world that you want to change? What is your purpose? Do take your time to think about this, because this is the biggest motivator. I didn't have this the first time around, and that just made me quit very quickly when things got difficult. But the second time, when I knew exactly why I wanted to do this, it was a different ballgame. I was always motivated. I was ready to go. It didn't matter if it took me long nights, long weekends. And just to let you know, I studied for the better part of a year. I was doing courses, I was practicing, I was doing projects, and it was taking me anywhere between 4 to 6 hours a day, most days, including weekends. So you do need motivation, because there is a lot to learn. And the better you know why you're doing this, the bigger your motivation is going to be. So how would I do it this time around? After you know this, where would I start? The first thing is programming. Definitely learn how to program. If you want to get into data science, you need to talk to computers, and computers only understand programming languages. And here is the first big thing. Do you learn Python? Do you learn R? Or do you learn one of the other languages, Scala, JavaScript, or Julia? Well, for me, this is a conflict that I hear a lot of people talk about, and there's a lot of resources out there. And although I am now learning R, I learned a little bit before, I would stick with Python, unless you already know R, or you really are crazy about R. The reason is simple. Python has a much larger community. It's very easy to learn and to get good at if you've never programmed before. And it has tons of libraries, and most people right now are using Python for data science. I mean, the biggest data science community is probably using Python. R is used for a lot of things. It's a lot better for a lot of things that have to do with data science. It has better statistics, better math. It even has better visualization packages, but the community is not as large. It is very easy to learn at the beginning, but it then becomes a lot harder to master. And it's just a little bit more complex at the end of the day. And it's going to be limited afterwards, in a sense that there's going to be more people and more job offers that want you to know how to do Python than R. Although, still, if you want to learn R, go for it. The other ones are optional. If you have time, if you want to learn JavaScript because you can do other things with it, if you want to learn Julia, if you want to learn Scala, go for it. The other reason I would suggest Python is because Python is much more flexible than R. There's things you can do with Python. You can do backend programming. You can do a lot of software development that you just can't do with R. But that's just my take. Again, your choice, which one, but learn how to program. Apart from either learning Python or R, you're going to see every single time you get into a course about data science, they're going to teach you SQL or SQL. Do you need to learn it? Yes, because we do have a lot of data out there in the world in relational databases. And SQL is the biggest, most common language to deal and to query. That's why it's called SQL query languages, to query information. So you need to learn to SQL, but you're also going to need to learn NoSQL. There are other kinds of databases nowadays, which are not just relational databases. There's key value stores, document stores, object stores, and one of my favorites today is graph stores, which is like Neo4j, for example. And these are completely different ways of looking at data, and they have different languages to access them. Not a lot of these NoSQL databases are SQL friendly, because they also do SQL. It's not just NoSQL, it's not only SQL, but do learn a little bit about this, especially if you're interested in a particular kind of data, like audio files, video files, graphs like me, or anything else that is not just your regular relational database. And the other thing that took me, I mean, I got very frustrated every time I got an error when I was learning to program. And I always thought that getting an error meant that I was doing something wrong. But this is something they generally teach us. They teach us if you do something wrong, you get an error, and that's bad. Not in programming. In programming, errors are your best friends. They tell you exactly what's wrong with your code. Learning how to read them is going to help you get better, help you to code better and to code faster. And if you decide to learn Python, yes, indentation errors are very common and very frustrating, but you will get used to them and it'll make you a better programmer. And the indentation errors happen because Python is a very good-looking code, has very good-looking code so that it's easy to read, and the indentation is important, but it also can get very frustrating. But just roll with your errors and learn from them. Then after you learn how to program, let's go back to mathematics. And please pay attention to one thing. We haven't gotten into any programming that has to do with actual data science. I did, and I regretted it later, because there's a lot of programs that teach you immediately to get into libraries like NumPy and Pandas, and they do this before they actually teach you the important mathematics behind, or they try to teach it to you all at the same time. So do get good at mathematics, especially these two parts. The first, of course, is statistics. There's an old saying by Mark Twain, lies, damn lies, and statistics. He is the one that made it famous, not the one who said it. And the truth is, there's a lot we can do with statistics. It's one of the most important science, mathematical concepts in our world, so we can actually experiment and do things and make inferences about big populations without having to have data on absolutely everyone. But it's also very easy to use to lie. That's why, to trick people. That's where this phrase comes from. But please do get good, really good at understanding everything that has to do with statistics, from means to medians, why they're important, why sometimes you want to use the mode and not mean, p-values, t-values, normal distribution, non-normal distributions, outliers, everything that you need to learn about statistics, learn it. This is the core of data science at the end of the day. You're just using computers to make it faster, but you need to know this, and the better you know this, the better data scientist you're going to be, because it's going to be easier for you to actually understand the information, the data that you have on hand. Apart from statistics, the probability of needing probability, 100%. You need to understand probability to do any kind of data science. And as you get into more complex models and you get into deep learning, you're going to need it even more, because probability is the one thing that is going to help you build better models, get your models to be more functional, to increase their accuracy, or to make them even more explainable. So you need statistics and you need probability. And yes, you're going to need more math, but not yet. After you learn statistics and probability, that's when we get into the libraries. As I told you before, I rushed into the libraries, and although I did have a little bit of background with statistics and probability, wow, it left me a lot of gaps, and I actually had to go back, and it made things a little bit more confusing. So it took a while to unravel everything, and I wish I would have just taken more time to understand statistics and probability better. But once you do, now you get into the big libraries, the ones that are going to help you be an actual data scientist. You get NumPy for everything that has to do with numbers. And please, when you're learning NumPy, do place a lot of attention into learning arrays. You're going to need them forever. They're very, very, very important in every single part of your data science career. You also have SciPy, which has to do with scientific Python libraries. They're very good for high computations. Then my favorite of all times, Pandas. Pandas is the library for data frames. And what is a data frame? It's taking the data that you have and building a table with it that you can use, you can change, you can modify. Pandas is going to be a library you're going to be using a lot, especially for cleaning and for cleaning data, making the data work, getting rid of all those terrible null values or NaN values, be able to actually get new information out of the information you already have, and building it in a way that you can use it afterwards to run your ML algorithms. Then, of course, Matplotlib and Seaborn, one is built upon the other. This is probably the best visualization library in Python right now. It's based on ggplot, which is from a package from R. ggplot is probably better at visualizing than Matplotlib, but Matplotlib is getting there and getting better. There's also other ones that are being built upon this one for geo-referencing information and stuff like that. So just keep at them and get really good at visualizing your data. It's going to be easy for you to understand it better and to explain it better. And the other two are Scrappy and Beautiful Soup. These are probably the best libraries out there right now to crawl for your data. A lot of the times you want to do something, but you just don't have the data that you actually think you need. So you're going to have to look for it one way or another. Then you get into machine learning. After these libraries, now it's time for machine learning. And machine learning, what you're going to learn is how to teach a machine to do something, or better yet, how to use your data to get a machine to learn something. And here you get into the basic algorithms. Now it's time for you to go into linear regression, logistic regression, decision trees, random forest, support vector machines, KNNs, everything that has to do with how you're going to help your machine discover how to make a prediction, how to make a decision, or discover some insight of how the world works. This is the stuff that you probably want to get into it right away. And I'm telling you, wait for it. Wait until you're ready. Wait until you have everything that has to do with programming, statistics. After you actually learned about the other libraries for data science, after you know how to interpret data a little bit, then get into machine learning. Before that, it's going to get confusing and it's going to be a lot harder. I went through that. Try not to. And of course, your libraries for machine learning. You've got scikit-learn, which I love. You've got PyTorch, which I'll be honest with you, I have not used a lot. And then you have TensorFlow and Keras, but you'll get into those mostly if you do deep learning after machine learning. So of course, after you do machine learning and you've learned enough of it, you want to get into deep learning because after all, neural networks are a lot better at doing things than some of the algorithms, well, a lot of the algorithms for machine learning. And they're sometimes better for a lot of things like computer vision and artificial intelligence. Not always. Remember, complexity doesn't always mean better. So once you're ready for deep learning, again, start with the math. I didn't start with the math. I got into the deep learning AI courses with Andrew Ng. And did I have problems? Did I start just not understanding what he was saying? And I love the fact that he always said, if you don't understand the math, don't worry about it right now. But I did worry about it, and it turns out once you understand the math, you understand neural networks a lot better. So do yourself a favor and do go and learn some more advanced math, especially linear algebra, which will help you with vectors, matrices, and tensors, which are very important for deep learning. Do multivariate calculus. It'll help you with derivatives, and especially with gradient descent, which has to do with backpropagation of neural networks. And principal component analysis, which will help you with dimensionality reduction. It'll help you get something that has thousands or even millions of features and condense it down in a way that you do have enough processing power to run a neural network. And after you do this math, then go into deep learning. And here it's up to you. Do learn about neural networks, then decide if you want to do computer vision, which is very particular, and you'll learn about particular neural networks for computer vision, or if you want to do natural language processing, and eventually you can get into artificial intelligence. But trust me, it's going to be a lot easier if you wait and you get all the stuff behind you before you get into deep learning. It's fun, it's wonderful, it's the first thing that you want to learn, but trust me, the better basics you have, the better you're going to be at this as well. So some of the insights from my mistakes that I made, first of all, build projects to learn. Don't just do the projects that you get in a course. Don't just copy the instructor's code. Actually build stuff from scratch, like saying, I want to do this, and just sit down and start coding and start building your own ML model, do your own neural network, because this is where you're going to really, really, really learn. It's going to take those concepts and really burn them into your brain. Leverage your domain knowledge. This is something that people think that you change careers into data science. And the truth is, you don't want to change careers. You want to take your career and you want to add data science to it. Because the more you know about your domain, the better you're going to be at doing data science with it. So if you already know about anything else and you get into data science, great. Focus on that and try to get as much insight from that as you can. If you know nothing about the project you're getting into, take your time to understand it. Like, for example, if you're going to do a project about soccer or about basketball, make sure you understand as much as you can about it before you actually try to understand the data. This is the one that really took me a long time to understand, and I didn't understand it until fairly recently, is show, don't tell. Companies are not going to hire you because of what you tell them you can do. They're going to hire you because of what you can actually do. So take advantage and get into Kaggle, do competitions, showcase your notebooks, get your GitHub account, put everything there, all your projects, everything that you're doing, share it with the world. Tell people on LinkedIn what you're working on, show them the results, and just put yourself out there. If you want to do a YouTube or a podcast about what you're going through while learning, go for it. The more you show, the better. Telling people what you're doing, getting the certificate, and don't get me wrong, I love certificates, but they're becoming less and less useful as time goes by, and in a few years, they're probably going to be worthless. People are going to hire you for what you can do because you've shown them that you can do it. Stack Overflow and other pages, but this is probably the better known one. This is part of your brain. From the first day you start programming to the day you decide that you don't want to do anything related with programming or data science anymore. This is going to be part of your brain. Even the best programmers out there, the best developers out there use Stack Overflow. It is impossible to know everything. And some of the things that you're going to need for one project, you're probably never going to need them again. Maybe yes, maybe no, probably not. So don't worry and don't get stressed out. You do not need to know everything. That's why we have the internet and we have wonderful pages like Stack Overflow. And the best advice I can give you when you're learning is join a group, and if you can't find one, create a group. Use Discord, Twitter, LinkedIn, Facebook, it doesn't matter. Get a group of people together who are going through the same things. Get together and do projects. Get together and talk about it. Be able to talk about what you're frustrated about, what's not working, what is. When you have a group of people, it helps you motivate when you're down. It helps you get your highs when things are working out. Your support group is going to be very, very, very important. And nowadays, it is a lot easier to get. Like, for example, a lot of you I know from the 66 Days of Data challenge by Kenji. Kenji is a great guy. You have a lot of videos and a lot of information from him. But if you join something like this, or you join an actual group that meets once a week on Zoom or Google Meet or wherever, you're going to get the support you need to push through the difficult parts. And finally, everything that you need to learn for data science, you can learn for free. As long as you don't, in some cases, you're going to get a certificate, in some others, you're not. Don't worry about the certificates, worry about the content. You've got free code camp, Coursera. A lot of people ask me all the time, but Coursera charges for their courses. Yes, they do, but you can audit practically everything. When you hit sign up, there's a little button that says audit. Just hit the button and you get all the content without having to pay a cent. You have Udemy that also has a lot of free content. There's a lot of pages that offer free coupons. Kaggle has a lot of courses of content for free. You've got Udacity has a lot of content for free as well. YouTube has all the content for free. cognitive class from IBM, as well as edX. They also have a lot of free, high-quality content. So anything that you need, you can learn it for free. So don't worry about having to spend money. Nonetheless, if you find a place where you like to learn and you want to give them money because they're doing a great job and you can afford it, go for it. So, as I said, can you become a data scientist without any previous background? And the biggest answer is yes. If by the time you are a data scientist, you find that it's being hard to get it's becoming hard to get a job, you don't get the interviews, or something's happening, ask for help. Somebody might be able to help you. Or there's always the great possibility of becoming an entrepreneur and starting a project for yourself. Believe it or not, as I said, if you start building a project, your chances go up that somebody will look for you and that you'll get hired if that's what you're looking for. So here we go to come to the end. If you need to contact me for any reason, here's the information. Just feel free to contact me on Twitter, LinkedIn, or you can read all that I have to say on Medium. If I may not answer immediately, but I always answer if you write to me. Thank you very much for listening to me. I hope it was fun for you as it was for me putting this together. I hope I didn't give you too much information because there is a lot of information on data science. And again, if you have any questions, now we can move on to the Q&A part of today's program. Hello, everyone. So I'm here. Wow, we have a lot of people. So guys, feel free. I'm here. Any questions? Go for all the questions. Thanks, Arthur. Yes, I like the shirt too. Big fan of the show. Yeah, guys, you will eventually get an email. Hey, William. You will eventually get an email, I believe, with the recording. And on the LinkedIn site, once I'll put the presentation on my GitHub on a PDF, and I'll share it with you guys, and I'll send it over to Diane so she can send it over the email as well if you need to. So, questions, comments, worries? So let's see. T-Bud, you were asking how to build industrial credibility in data science. Build stuff, as I said, build projects, get into something you're really interested about. If you're interested in a particular industry, like for example, if you're interested in the wind power industry, then go look for data sets and build interesting stuff about it. Guys, just in case, if you hit that, if you ask for video access, you'll get video access, and that way it's a lot easier. You can ask me the questions directly, and we get to chat for a bit. How do you know when you're ready for a job in data science? You don't. Truth is, you can never be 100% sure you're ready for a job. As long this feeling that you're not good enough is probably not going to go away anytime soon. It happens to even the best in the industry. This is a very high-end industry in many areas. There are a lot of incredible people, and even them don't know everything. So there's a lot of room for a lot of things. So you're never sure. Just keep working at it, keep practicing, and you'll become a lot more confident. Hey, Christoph, go ahead. sure you're not muted. Hey, Ankur.
Hi, Jack. Hi, Jack.
I don't know if you can hear.
Yeah, I can
I'm
hear
the
you.
one that can hear you. Give me just a second. Huh? No,
Am I audible
I
to
can't
you?
hear you.
Hello.
Okay, now go ahead. Sorry, I couldn't hear you. I had the side muted.
Jack?
Yes, perfect, Ankur. I can hear you perfectly.
Yeah. I just wanted to ask, see, I don't have any, tech background. I'm not coming from any kind of a computer science background. And yet I decided to migrate my career into the data science field. I am pursuing my MTech in data science here in India. Now I'm looking forward, in various other things, but I am getting some problem related with the coding because I don't have any background. So I don't know how to cope up with that particular thing, the coding part and the other technicalities that may required during the course, during the program.
Well, here's the thing. Not coming from an actual background in data science or a scientific background, that's not really a problem. Just learn a lot about the actual scientific background, and whatever industry you want to get into it, just go into and learn about that industry in particular. I understand that a lot of companies right now, it's going to take them a while to learn. They're asking for a bachelor's degree in computer science or mathematics or statistics to give you a job. So the way to counter that, as I said, is that do projects and put them out there. Show people what you can do, and then they'll take you seriously. But I do understand that it's hard, especially nowadays, to get a job when you have no background, because companies still are thinking in a very old-fashioned way that that's what you need. There's a meme that was shared by Elon Musk a couple of days back, which is wonderful. You know, the coding during the interview is like Godzilla versus Motaru, and then the actual job is like shoveling snow. You know, they're completely disconnected from the reality of one thing and the other. So all I could tell you is join projects, do projects, join competitions, and show people what you can do.
One more thing, Jack, I just wanted to ask, if I want to pursue my PhD in data science after completing my MTech program, then what exactly I should look for, for that particular thing, aspiring PhD, particularly from outside India and any renowned institute globally?
Wow, there's too many of them. I mean, it really depends on exactly what you want to do. My suggestion, as always, this is something I learned a little while ago. I don't have a PhD, or I do have a master's degree in psychology, but I never went for my PhD. But instead of trying to look for a program, talk to the teachers, talk to the professors who are working on a particular field, and they will help you a lot better, and that will give you a better chance of getting a high-end degree. And even to get a scholarship than if you just go through the normal programs, because the normal programs are very generic and you probably want to do something very specific.
Okay. Thank you so much, Jack. Thanks so much.
Anytime. Hey, David or Stan.
Hey, do you hear me,
I don't know
Jack?
who connected to. Hey, David.
Awesome. Yeah, thanks for having me, first off.
Sure.
I recently graduated from a data science 12-week boot camp. I actually transitioned from a sales background, and I'm pretty confident in my ability to tackle creative problems and put projects on GitHub. But my question is in terms of the coding speed, the ability to tackle problems fast. How fast do you think is good enough for being competent in, say, an interview coding challenge or something like that?
Well, that's the thing. The coding challenges for interviews, apparently they're looking for Usain Bolt type speed sprinters. They want you to run the 100 meters in 20 seconds. The truth is that is not the pace of the job. The job is going to be a lot slower. Your ability to tackle coding problems fast does not translate into being a good data scientist. And that's a mistake that most of the companies hiring data scientists nowadays are having. But that's another big issue, because the problem is that companies don't understand what a data scientist is yet. So most of them are looking for data engineers, for programmers, for people who do other things apart from actually being a data scientist. So probably the companies that are being the most successful and hiring the best people, what they're doing is, instead of giving you a coding challenge that you have to do fast and on pressure right there, they give you a project and say, hey, here it is. If you turn it in fast, a couple of days, they know you're very interested and they know what you're doing. But speed coding challenges, if you're getting hired by a company who's going to hire you because you're very, very quick at coding, you're probably going to hate the job.
Yeah.
It's not the job that you're really looking for. And be honest during the interview. Ask them, how is this going to translate to my actual job? Because you never said that I had to be a speed coder.
Yeah, that's a great point.
And I can tell you, I'm a crappy speed coder. If you give me a challenge, probably right now against all of you, if I don't come in last, I'd be very surprised, because I'm very meticulous and I'm very slow, because I need to understand the problem. Then I'm going to sit down and write it, write a few squiggles on a piece of paper. And then I'm going to sit down and write code. And I'm going to re-engineer the code about 20 times, because especially in Python, I love list comprehension. So I want everything to be in one line, everything. So I'm going to try to do that. So that's going to be a very slow process. But the advantage is that the actual data science job is going to be that slow.
Do you think data structures is important in data science? Absolutely. Okay. But what about the depth of it?
It depends on the structure, but they are very important depending on what you're doing. Data frames are vital, definitely. And then everything that has to do with vectors, matrices, and tensors, especially if you want to get into computer vision and neural net and everything that has to do with neural networks. And there's no getting around that. So data structures are vital. And nowadays they're becoming even more important, because we have so much data and everything is in such a different way. Now you have data lakes, not databases.
Yeah.
So structures are very, very, very important. I would say that unless you want to be a data engineer, if they fall on the engineering side, retrieving and loading data, don't worry too much about them. But if they have to do with the actual work, with how your algorithms are going to interpret them, they're vital.
Awesome. Thank you very much for the feedback.
Sure, anytime. Hey, Stan.
Hello. I got a few questions, if I may.
Go for it.
First of all, I am in a different stage of life than I see most of the people in this world, right? I have a mortgage to worry about. I have a financial responsibilities to worry about. I have a very demanding full-time job. I have other activities. I don't work in data science on my job, and I have no option to do anything with that. So giving away my time for free on projects is very, very limited. So what's your advice on somebody that has a minimal amount of time to invest in some type of project? That's question one.
Okay, so if you have a minimal amount of time to invest in a project, find one very good project that it doesn't matter if it's going to take you a long time. Try to find something that you already have a data for, and something that you're very passionate about, even if it has no industry value. The other day, somebody was doing an incredible project about creating the perfect NBA team with data. So if you're passionate about something like that, a sport or politics or whatever, just something that's going to be interesting and that shows people that you know what you're doing, that it's not necessarily going to take a lot of time. Something where you can find a Kaggle data set that's already clean and stuff like that. Or the other thing that you can do is look for a small group of people that you can collaborate with, and that they're okay with you only having 20, 30 minutes a day. But yeah, you can still do it. I mean, just in case, I started learning data science after I turned 40. So I get where you're coming from. I had a little bit of time in my hands, but I was also running my business at the same time.
You were young.
Oh, thank you.
Second question. So I have managed to do a few, or looking at a few projects, but I try to get paid for them. So I'll have customers that on my side job. How do you, and obviously you can't put that on a public site to say, here's what I did, right? Because they're private entities. One's even, to the point I can't even talk about it most of the time. How do you put that into something to show I've done it?
Blog. Just get into Medium or something like that and write a blog about the project that you're doing and just change the specs. If you were working on a project that was about the NBA, then talk about your soccer project. And just, change the stuff that you can do, but, and talk about it instead of actually showing the actual project that you can't.
Put it over here.
All right,
That's what I would
one.
do.
Yeah.
One more.
Go for it.
So my real job or my real life, my superpower is communication, not data science. And I'm looking at, from a data science point of view, being a data storyteller, one that's embedded with the data science team from the beginning to understand the customer journey, what's the value of the project, how it's going to play out. Unfortunately, I don't see a lot of job postings or anybody that actually understands that or is willing to pay for that. Is that something, am I dreaming?
No, you're not. From my perspective, it has to do with the fact that companies are still not completely understanding what a data scientist does. Communicating is one of the most important parts of data science, and being a good data storyteller is vital. See, that's the one thing that you could probably do to showcase your skills. Do a blog or a video about storytelling with data. I'd probably, again, combining everything that you told me, look for a group of people. Get a couple of young people who have nothing better to do with their lives than study data science, and get together with them, and you can actually help lead the project and help them with the communication part, which is something that most people can't do. So you already have a big advantage.
Okay, no, thank you.
Sure.
And I sent you a LinkedIn request.
Perfect. I'll look at them later.
Not a problem. Thank you.
Talk to you soon then. Who was after Stan? I lost track. So let's say, I think Andy, right?
Yes. Give me a
Go for it.
Oh, hey, Jack. I have to say, you, David, and Stan had awesome conversations about what you two are talking about. And I want to follow up with what you have said about the thing where you said some parts of the data scientists where you have to be speed coding. I did some practice questions on that from one of the folks who I go to school with, and I was wanting to solve that all myself. And the thing is, when you talk about speed coding, are you talking about saying you have to solve all the questions within a set amount of time, or do you mean you have a whole day to do it? What do you mean by
Oh, no, we're talking about interviews where they give you a coding problem and you have to solve it in the next 2 minutes.
Oh, it's not that quick. It's this is what happened. One of the practice questions I got, well, it was 3 of them, and you got 60 minutes to solve it.
Well, 60 minutes is decent. But here's the other thing. Again, the day-to-day work, you don't have someone on top of you telling you things, or knowing that you have the pressure. Can you imagine, just think about this. Imagine doing your first math test when you're in high school and you have the teacher literally on top of you, looking at your paper and making faces whenever you're doing something. That's definitely not the way you do it. And when they give you a timer, 2 minutes, 3 minutes, I understand what they're trying to do. but I don't think it translates the best way to data science. But again, most companies still don't understand what a data scientist is, and most of them are looking for a jack of all trades that can do everything from data engineering all the way to putting out a data science product. And this is a very complex thing, but again, data science is a very new career. It's a very new job. So it's going to take a while for companies to understand what they're doing.
And another question I have is that when I read through the job descriptions and all for these positions, I've seen that some places, as you said, they want the jack of all trades. Some places they say they want this and this and this. And the thing is, it also depends on where you're at geographically and geographical area and all. And so the thing is, what I've seen in my end is that I've seen more data science roles are being treated like a software engineer. And the thing is about what you say with the questions, it doesn't sound that it was technically a data scientist interview. It's more of a software engineering interview. So what's your take on how to tackle those?
Those are very difficult to tackle. It's just a matter of, I mean, nowadays remote work is becoming more common. So start looking for a job in places that are a little bit more advanced in the data science industry. And again, the more you showcase yourself, the easier it's going to be for someone to look for you. And instead of going through the normal job channels and coding interviews, it's going to be more direct. And again, for me, the best option is always build something that people want to buy and sell it, so you can be your own entrepreneur.
Thanks, Jack. That's all the questions I have for this session.
Anytime, Andy.
Thanks.
My
Thanks
pleasure.
for answering. Take care.
You too. Dave, go for it. Hello, Dave. Can you hear me? Okay, so no Dave for now. Navia?
Hi, so
Hey,
can you hear me well?
perfectly.
Okay, so I'm actually really young compared to most of the audience here. I think I'm 16. And so I'm starting data science because I'm doing machine learning research projects. So like, for example, one project I'm doing is we're using different models such as an RNN, SVM, and KNN to determine like which sleep stage is most affected by having atherosclerosis. And then I'm doing like two other projects too. So like one of them is like seeing like a relationship between city walkability and COVID-19 fatality. And then the last one is seeing like, there's like different brain waves that go off, right? Like beta, alpha, delta, so forth. So we're trying to see which of those is most affected by when you push like a brake pedal. So I wanted to ask, like for projects like these, like how, like what is your advice on reaching out to experts and professors? Because like as a student, like especially within like the research in our area, there's like people who do data science, but they're not necessarily experts, so they may not have the best advice. And then since we're like beginners, it's kind of like leading us in the wrong pathway too if we don't get like expert advice.
Okay, first of all, wow. I mean, those are some amazing projects, and the fact that you're only 16. When I was 16, I was definitely not thinking of stuff like that. I know it didn't exist, but not even close to things on that level.
Mm-hmm.
When you say reaching out to experts, you mean the researchers? Like, I mean, experts on the specifically field, like for example, COVID experts, epidemiologists, and stuff like that.
So like for the brain research, I'm more like a neuroscience. Like I'm really interested in neuroscience. I'm trying to do a lot more neuroscience projects. So for those, it's more like people who are doing technology for the brain. Like those are like the experts. Like for example, like a lot of professors at Columbia and Zuckerman Institute are doing that.
Got it. Well, my suggestion is, believe it or not, and this comes from experience. A few years back, I work with my wife all the time.
Mm-hmm.
We're entrepreneurs together, and we practically do everything together. And the thing is that we were looking for people to help us with things that had to do with neuroscience and behavioral economics.
Mm-hmm.
And what we did is, instead of just trying to read the papers and buying all these papers, which get to be very expensive, we actually started knocking on doors. You know, send an email to a particular professor and tell them, hey, I'm Jack, and I'm Jack, and Oriana, we're doing this, and we want to know more about your research. You'd be surprised how nice and wonderful people tend to be, and how willing they are to share their experience and even their research and their data sets.
Yeah.
If they can. So just reach out to them, talk to them, tell them what you're working on, show them some of your work, have a link to somewhere where you're putting everything so they can see that you're that you're for real, that you're not just asking because this is, you want to show your teachers at school that you talk to a professor. Just knock on their door. Most of them, I'm not going to say all of them, but most of them are nice enough that they're going to answer back. Just give them some time. It might take them a few weeks to answer.
Do you recommend like cold emailing, or do you recommend like LinkedIn messaging?
Ooh,
or like a combination of
difficult. That's a difficult one to answer. I mean, because it doesn't depend on you, it depends on them. You know, for example, me personally, I prefer LinkedIn, but some people prefer email. Some people prefer WhatsApp. So whatever, you know, I would say that if you have their email and their LinkedIn, write to both of them, and you know, hopefully they'll answer on one of them. But Thibault said it. A lot of scientists are not on LinkedIn. So probably the best place to reach them would be at their school's email.
Okay. And is there like a certain time of the year that they respond the most, like a certain season or anything?
It depends. I mean, it doesn't depend on school cycle. It depends on the research cycles.
Okay.
So that's a difficult one to answer.
Yeah, that makes sense. Yeah. And then I had one more question. Do you have any advice for data science projects, like specifically in the realm of neuroscience? And that's like more like in terms of like models, libraries, or like any like certain databases to examine. Because like right now I'm doing like a lot of like, I'm trying to do a lot of brain ML and deep learning projects. But in the future, I want to launch like AI for the brain, kind of like similar to like Neuralink, which is like Elon Musk's thing. So it's kind of like I want to build up towards that because ML is like the base for AI.
Of course. Well, here's the thing. Most of the stuff you're going to find, and that's very interesting. And again, Kaggle has a lot of curated data sets for MRI imaging. There are, just make sure that you're getting into like something that's very specific. But there also are several very interesting research with photos for things like personality, for emotional reactions and stuff like that. So it really depends on what you're trying to do. And there's also, the other ones, I'm just not sure where they are. That's very interesting research, has to do with the brain pathways.
Yeah.
Everything that has to do with how the neurons work. The thing is that they have a lot of raw data on that's not really processed. So it would be interesting to get into that. I mean, it depends on what you want to accomplish.
Yeah.
If you know what you want to accomplish, it becomes a lot easier to know what to look for.
And also, this is just like out of curiosity. Have you ever done any ML or deep learning with EEG or EOG or EKG data?
I've done a little bit with MRI, but I do most of the stuff I do, since it has to do with people analytics. I work a lot with personality and psychometrics.
Okay.
So I want to mix some of that in the future with brain scans, but I haven't done it yet.
Oh, okay, that makes sense. Do you ever like mentor research or like provide help for research projects?
Not yet, but if you write me an email and it's something interesting and I have time, I'll be happy to help.
Okay. Thank you so much for answering my questions.
Sure. Anytime, Nadia.
Thank you.
And keep up the great work. Sarbotam.
Hi, Zach.
Sorry if I completely messed up your name.
That's exactly correct. Yeah.
Perfect.
So I have a few questions. Like, so first question here mine is like, how do you approach if you're going for your first data science job now, based upon the fact that you have a pretty like average profile, like based upon the project or everything, you have set up the LinkedIn as well as the GitHub profile, and you have some project to show on live web app kind of thing. So how would you approach like for applying your first data science with everything set?
My what? Yeah, how would I approach what? I didn't get it.
Like applying for your first data science job if you are now.
Well, the way I would do it again, it's I would start showcasing my skills. And believe it or not, I would start applying to every single data science job I could find, even if I don't want the actual job, just to get the experience of the interview. Because here's one thing, especially if you haven't done this before, interviews can be very, very, very intimidating. But the best thing you can do is just go to interviews until you get good at them. So just make sure your CV is well written. It doesn't have to be big, just one page, very, very to the point, and just send it all over, apply all you can, and get your experience at getting a job. I know it sounds weird, get experience at actually getting a job until you either get the job you want or at least a job you like. Just don't settle for a job you really, really, really hate. The fact, the whole experience thing, it's very complex. It's really, really a complex world, because one of the things that happens when searching for a job is that most people think that everybody's looking for the same, but they're not. Everybody's looking for something particularly different, and there's no way to know exactly what that is. So the best thing you can do is just get good at interviews. Get good at sending your CV, get good at applications, and get good at interviews. And the more you do, the higher your chance. Do not worry if they say no 400 times. You'll get it at 401 or 402 or 403. Just keep at it.
I got it. So the hard fact about the applying to the job portal is that, like, they are like more of a kind of a trash bin. Like your CV doesn't pass, or people say that they prefer the best way to apply for a data science job is to go through like cold emails and approaching the hiring decision makers, not through the.
Yeah, I mean, just go on LinkedIn and look for whoever's looking for a job and write, tell them, apply, do whatever you need to do, and just keep going. I mean, make it your full-time job to get a job. I know it sounds tiresome, but it's the best way to do it, especially in data science, because again, data science is not like other jobs right now. It's not like, okay, if you want to be a salesperson at a company, everybody knows what they're looking for in a salesperson. Almost no one knows what they're looking for in a data scientist. And that's the big thing. So probably getting a job in a data science is the hardest and easiest thing at the same time. Because on one side, you might go on 500 interviews and everybody says no. Then you suddenly go into just one interview and they say yes, because nobody knows what they're looking for, not even you. Even data scientists don't know what to look for in other data scientists yet. Yeah. So just keep going. I mean, don't stop until you get what you want.
That's good. Thank you. That's
anytime. Sure. Hey, Svetlana.
Hey, first of all, wanted to say thank you. Yes, thank you. I'm dialing in from Houston and Texas. Yes, and a couple things I wanted to add. I totally agree with pretty much every point that you have stated in your presentation. What a lot of people don't downplay your software development skills. So if you have a formal training in that field, it is very important, and companies will appreciate that, because the configuration management and when you're working on a production type of environment, you definitely need adherence to all the best practices. So do not downplay that. Learning how to of the data science and how to analyze, interpret, and present that information is great. But then when it goes into a production, we probably have, all of us, experience losing code, overwriting, and so on. Every once in a while, maybe not every time, not everyone was, probably most of us were lucky, but it is one of those basics that you learn in software development. That's one. And I totally also agree with you as far as when you answered to a previous person asking, that applying to just about everything, and keep in mind that companies indeed do not know what they're looking for, and very often data science jobs are hidden under full stack developer. I mean, who would have thought, right? But it is pure data science after that. It's just maybe masked by something else, because a lot of large companies have a specific positions that data science does not exist or did not exist when they created that. So again, be flexible on what you're applying and what you're searching for. Not always straightforward. You put data science and here's boom, all the jobs coming. It may be a different, but I want to encourage everyone. It is indeed is possible, and you have a field that open. Depending on your background, still a lot of niche is open for exploration and monetizing. And so thank you again. I'm looking forward to interaction with you on LinkedIn. So it's keep up. You're doing great with inspiring others.
Thank you very much, Svetlana, and talk to you soon. Mohsen, hey.
Hey, hello. It's nice hearing about your advice and stuff. I wanted to ask a question about getting job into data science. I've heard a lot of people like transferring to a data science from a consultant, a data analyst role. What's your advice, like, or changing job from these fields, related fields?
You mean moving from data analyst to data scientist?
Yeah, and a consultant roles and other roles as well.
That's a really good question. I don't have an answer to, mostly because I've never been a data analyst. I think there's still in the industry as a whole. I don't know if the word is confusion, but there's the whole industry that has to do with data analytics, data science is still trying to figure out what exactly is what, because right now these are all very new words in every sense of the word. But if you're already working as a data analyst, what I would suggest is if the same company you're working at is transitioning towards doing things in data science, then try to show them that you're the right person for it, that you can actually do it. And if the company you're working for is not looking to transition into that, then again, just go out there and start showing people what you can do as a data scientist. Because I mean, there's no actual transition. There's nothing written yet that you can get great data scientists out of data analytics. So I really don't know what's happening specifically there. And as somebody mentioned, it depends on different parts of the world. There are some parts of the world, especially in Europe and the US, and actually, believe it or not, there are a lot of places in China are very much advanced in understanding the data science roles or the different data-related roles than countries in other parts of the world. So this is a difficult question, and I don't know if I have the right answer for it.
Oh, that's perfect. Well, thank you very much for your honest.
No problem.
Thank you.
You're welcome. Carlos.
Hi, Jack. How are you?
Todo bien. Salud.
Okay, so I really appreciate your time to share your story with us. That is something that we are looking for, because it's nice when a real data science, expose their lives out there and see, okay, so this was my path. So let's start. So I'm started data science by myself a few years ago, and I started in R, deep learning, well, not deep learning, it's steep learning curve, but I really enjoy through Coursera. So I always like to learn by myself. I don't need a necessary education system to do it for me. But anyway, so I start late in life. My background, it's in Air Force. For 16 years, I had my own business in marketing kind of a while ago, and I just left everything behind, moved to the United States. So I'm starting over. Okay, a few years ago, different culture, different language, different everything. And now I was accepted at UCSG for data science major. That for me was great. And everything that you told us, like you said, the importance of math, what you should learn first, what comes first and come after, is the sequence that we learn. Like so, oh, okay, so that is nice. But because of it's a fast pace, not just for UCSD, but all universities in a whole, we don't have time, like you cannot digest the information because it's like they throw to for project, for, meet people, but actually we don't have time that it's important. And some gaps that I need to fill because I start late in life. So I need to go back. Oh, I've learned this math, years ago, but I cannot remember, but I need to better understand, as you said. So what do you suggest in this case?
Well, the thing, that's one of the things with the regular programs at the university. They will throw everything at you and they'll go at their own pace and not at your own pace. I completely agree with you. I'm a big fan of online learning, do-it-yourself online learning. Coursera is probably my go-to place most of the time. But the big question is, what's your biggest issue? Not having time to go back and learn something specific, to understand it better?
No, actually, I'd like to learn in different ways. I don't think that I learn in a linear way. Okay, so every time I'm trying to get things to better understand my life experience, though that make me understand better. The problem is not exactly that. It's the lack of time that we have to learn things different. For example, you mentioned about the importance of statistics, the importance of math, and okay, I agree. But then on the other hand, we need to show the people through visualization. So what kind of visualization I have? Oh, ggplot. So let's learn ggplot. But because I'm dealing with R, but I have other classes with Python. So you know what I mean? Like it's a juggling with so much information. So, and I've been asking different people like, okay, I have all the recipes, I have the ingredients, but what comes first, the chicken or the eggs? So I it's hard to figure out.
Well, I think that's the hard thing in itself with data science. Nothing comes first. Everything hits you at the same time. What I would suggest is get really good at something. Like, for example, if you're good at understanding data through visualization, whenever you get stuck, go back to learn that tiny bit that you're missing, whether it's, oh, I forgot how to deal with p-values. I forgot how to do a violin plot. I forgot how to do this. And, get more interested in what you're more interested in and what you want to focus yourself in. And the rest, like we do with Stack Overflow, you can do the same with other stuff. I mean, it's probably not the best way, but you can, oh, I don't know how to do this. Let's look it up. Oh, I didn't understand this. Let's look it up. And just try and take, about 5 to 10 minutes every day to make a list of your gaps and start reading articles or watching a video or something that'll help you fill in those gaps, because I understand I still have them. Every time I see, like for example, the other day I was talking to someone and they reminded me that there are more algorithms than ReLU and Sigmoid for neural networks. And I'm like, oh yeah, there's more. I forgot about them. And I had to go and read back to understand that they're there and that I could have actually used them. But I understand, yeah, you're going to be juggling a lot of stuff. What I wrote down today, that would be the perfect ideal path. It probably doesn't exist for anyone.
Exactly. I mean, yeah, I'm joining Coursera, Data Camp, LinkedIn Learning. So every time that I can come up with, different solutions or different insights, I'm getting. And another question is,
the best solution is understand what you're really bad at and get somebody to help you.
okay. And the second question is about projects is, should I first come up with a question that I want to answer? And for example, I'm a passionate about coffee. I'm a coffee lover. I've worked with Nespresso a while ago. And so should I come up with the question and then to try to find not the perfect data set, but like that approximated or many data set? Or should I come up with the data set first and then no? First.
You were on the right track. Always ask questions first. Get the question and say, I want to answer this question. Go look for data. If you can't find the data, or the data is, telling you go this way, go back and change the question. But remember, this is going to be an iterative process. You move forward, you go back, you go again forward until you find it. And the more you understand this iteration, it's just like any algorithm. You go forward, and especially neural networks. First you go forward, then you have back propagation, then you forward propagation again until everything lines up. So don't worry about it, but always start with a question, because if you don't ask the right question, you're never going to find the right data set, first of all. And you can always go back and change the question if you see that the data is leading you somewhere else.
Okay. All right. Thank you so much.
Anytime. Shruti, how are you?
Hi, how are you, Jack?
I can hear you perfectly, so go for it.
Okay. So hi, Jack. I've been following your work in 66 Days of Data with Kenji on Twitter a lot, and it really helped me a lot. First of all, I want to say you that. And I'll introduce myself. So I'm 18 years old. I'm Shruti. I'm currently doing second year college, and the thing is, I'm doing a business degree. I'm doing a business degree as business administration degree. I'm in the second year college. So what happened is, now in the lockdown, I came across the term data science. I got interested in it. I started researching about it, and I always was good programmer before. But then again, I got a very big gap in my studies, so I never went back to programming. I came to the college and I started learning the business thing. So again, I started doing all this stuff. And so I came to know that if I wanted a job in the future, not right now, I'm looking for internships totally right now. So if I want a job, I need experience now. To get experience, they only say internship is the way. So I think, so I have did 2 internships. So the only problem is they are non-profit organization. So so they give a project-based internship. They give you projects, you have to complete it. According to that, they'll value you. So I just want to know, does these internship matters? Like when you go for a job of like for a interview or give you a resume, are those job or those interviews, like what I'm saying, yeah. Or those like internships, is it worth?
Again, this is one of those big questions that it depends. For some companies, yes, they'll be valuable. For others, not so much. Again, the internship itself is not as valuable as whatever you learn during the internship. So especially if they're for nonprofit organizations, you probably can share the whole process and everything that you're learning from it. Just ask, just in case. And showcase what you've been learning during your internship. Because at the end of the day, internships are mostly about getting hands-on experience to get your first job. That's it. That's the reality. So, and again, more than are they valuable, what I would say is try to, whenever you start looking for a job after your internship, try and get a job in one of the companies that actually value the fact that you did an internship, more than actually worrying if they care about it or not.
That makes sense. So my other question is, like, I'm from a business background. I said I'm doing a business degree right now, business administration. So when it comes to domain, like I always get so doubtful myself that which domain should I look for? People say what you're interested in. So I'm interested in business most probably. But if you see, every company is an entrepreneur company, and it's like it's all a business about. So I always think, which domain should I choose? Like, do you have any specific way of choosing, or like it could help me to choose a domain?
Well, here's a question. If you're into business, what are the interesting questions for business? What does a business want to know? What does a business want to understand? Or, find an industry that you're interested in. It doesn't, I mean, for example, if you could get a job in business right now, what industry would you look for first? And try to see what's happening in that industry. And how, because probably the biggest thing you need to ask yourself before you start any kind of data science project is, how do I bring value to X? X being this industry or group of people or company or whatever. Because that's at the end of the day, that's what we want to do. We want to bring some kind of value. So what is the value that you want to bring to whatever industry that you want to bring it at?
Yeah, I understand that totally. So last question. My last question will be like, how do I say it? Okay, so in the project, when I do a specific project, is it necessary for it to be an end-to-end? Because like web scraping is not something I'm familiar with, not till now. I would rather take a Kaggle data set and work on it than scraping the whole data, because I have no idea about web scraping at all. So like, do you think it is necessary to learn web scraping like at this point of time when you're starting from end-to-end projects?
That's a really good question. Well, it depends. I would say yes. You definitely want to at some point do some kind of web scraping and learn how to get data for yourself, because you are never going to get the data set that you want. I mean, that's what was the question. I mean, it's very easy to find a data set and then build something upon that data set.
Yeah.
It's a lot more difficult to build a project and then find the data that you actually want. And it's never going to be perfect. So it's always going to have issues. There's always going to be things, and you're always going to want more data. So yeah, it's important that you learn it. I don't know if you definitely need to do end-to-end, but again, it all really depends on what you want to do. I understand not liking web scraping, just like a lot of people who are learning data science. Most people say, I hate cleaning data. Yeah, of course, cleaning data is boring, but believe
That's
it or not,
important,
it's probably very, very important. But nonetheless, there's actually a company in England that that because they know that people don't like cleaning data, they do it for you.
Oh.
So think about this. It's becoming very valuable to be able to clean data.
They made an opportunity out of it. That's actually a great thing.
Exactly. They're called the data guru.
Should look at it now.
Yes, go for it. They're on LinkedIn. They're a lot of fun.
Yes, but Jack, thank you so much. Like, I really follow you on your Twitter and everything, and your work is amazing, as of course all your articles and everything. So yeah, thank you.
Thank you. We'll be in touch, guys. Let's do 2 more because I need to leave. So let's see, Marwani.
Yes. Well, hello, Jack.
Go for it. How you doing?
Good. I'm good. So basically, I have a question regarding cybersecurity and data science. So, in a more computing context, like, that cybersecurity is undergoing massive shifts in technologies, especially in the recent days as data science. And definitely AI and data science, I believe, is going to be the driving factor to shape that in the future. We're talking about the next 10 years, for example. How would you take, what's your thought and what's your take on, like, how would it be possible to extract like security incidents patterns, and using, data-driven models and things like this? And how would you tackle like the fact of using analytics to make a security system automated and more intelligent? Like, do you have any thoughts about this? Like providing a machine learning approach based on multi-layered frameworks for the purpose of security, cybersecurity modeling?
Well, I mean, if you go back on history and everything that has to do with security and cybersecurity, here's the thing. Yes, of course, we're going, I mean, we already, as a world, we already are applying ML to cybersecurity for incident discovery and stuff like that. And I'm sure it's going to get better. You know, you're eventually going to have completely automated systems that protect for cybersecurity. And eventually somebody's going to, you know, they're going to build ML systems to destroy the ML systems built for cybersecurity.
Yeah.
It's definitely not my area. I'm not into cybersecurity at all.
Yeah.
But probably it's going to be something very interesting. It's going to be something that I have no idea where it's going to end up. But it's going to be like the arms race that security has always been. You know, there's going to be people building security, and there's going to be people breaching security, and then somebody's going to build security on top of that. And it's going to get even crazier when we get quantum computing going.
Definitely.
A lot crazier.
Yeah.
So, but honestly, again, in particular, what's happening with that, I have no idea. I'm going to leave that to the people who are really interested in cybersecurity. Yeah. I'm not one of them. Yeah. It's not my cup of tea.
Yeah, definitely. Because you know, like, since we've seen like the increasing dependency on digitalization and the IoT and various like industries, you know. Therefore, like, I believe more and more security incidents and breaches are gonna we're gonna be facing more of those. So definitely, data tackling those problems, integrity of the whole system in itself is definitely gonna be like something that we're gonna be looking forward to for the next years. I believe it's gonna go hands in hand with AI advancements in technology.
Yes. It's going to be, they're going to need to, because there's going to be more ML systems, more AI systems, and definitely, you know, they're going to need different kinds of security. It's like, I was reading an article the other day, which is probably the biggest thing, the incredibly secure cybersecurity that we definitely need before we're actually comfortable in all of us getting into autonomous cars.
Exactly. Something, yes, that's something really in the spectrum of it, definitely.
Exactly.
All right.
So yeah, it's an issue, and there's going to be a lot of challenges, but that also means a lot of opportunities in data science and cybersecurity.
Exactly. So like basically a fusion of both fields could even create specific position inside big top tier companies or things like this.
Exactly.
Yes.
Definitely.
All right. All right. Thank you, Jack.
Sure, anytime. Great talking to you. And finally, Anvesh, great to see you.
Yeah.
We read each other, but this is the first time we're meeting face to face.
Yeah, exactly. And thanks a lot for sharing your path to data science and your learnings on all of this. And the project that you're doing is really great. It's really interesting how it's unfolding. I'm
getting surprised too.
Yeah, I have a quick question. So on my path to data science journey, I am sure if you would have felt the same, there is some or the other shiny tool that comes up that seems to be something that we can try out, and then we just deviate from the path that we are on directly. So if I'm learning Python and I find, okay, there is some tool on IBM Cloud that is doing auto AI, and I try that out, and soon enough I realized that I'm actually away from what I wanted to do. So how did you keep a track of where do you want to go and stay away from the shiny new tools?
Okay, so I have a list. I have a list of all the wonderful shiny new tools that I want to learn from. And they're right there, like it's a list. So once in a while, I'll look at the list and I start either crossing things out because they apparently, you know, here's the shiny new tool and suddenly nobody's using it because it sucks. So, you know, that's it. I don't have to worry about it. Or I actually go back to the list whenever I'm actually looking for a tool that I would really want to do this. But I understand, I just try to stay away from things. I mean, I decided I don't want to be the first, the early adopter of anything. I'm going to let other people be the early adopters. And once the early adopters say, this is something that we want to use, it's worth using, then I'll start using it. Because as you said, if not, you'll spend all of your time learning to use new tools that are not necessarily the tools that you want to use. And whenever I'm actually working, even if somebody says, oh, look, there's this, the GeoPandas is now out, and I'm like, I don't care, it's still on 0.8. When they get to about 1.5, then I'll take a look at it. And that's my policy, and just stick to the usual tools, because I'll give you an example. I know someone who's been working with deep learning for a system they're building, and they started building a neural network. Then they decided to do a convolutional neural network. Then they did an adversarial neural network. Then they said, oh no, let's work with LSTMs. And the last time they wrote to me, oh, I'm trying to build a transformer now. And I'm like, dude, you're never getting to the end. I mean, I understand it's always exciting to try a new tool and to start, but finish building your network, finish building your model, see how it works before you start building another one. I understand it's very valuable to build several models, but again, if all you're going to get from Model 1 to Model 2 is a difference of 0.1, 0.2% accuracy, yeah, it is worth it, but it's worth it in the long run. It's not worth it right now. So first finish and then try to build something better. And stay away from the shiny new toys. You know, but I understand. It's like a kid at a supermarket in the cereal section. They want everything because it's colorful, it's shiny.
Yeah.
So stay away from the aisle.
Yeah. Thanks a lot. That's really great.
Sure.
And thanks a lot for your presentation. Anytime. I finally got to see it. There has been a lot of build up before that.
No. Thank you for your support, and we'll still stay in touch on the networks, on LinkedIn and Twitter. And guys, really thank you very much for everything, everyone. It was I had a blast. So let's do this again, and I'll send the presentation to Diane so she can send it all over to you. And if you need anything, again, just look me up on LinkedIn, look me up on Twitter. I always answer, even if it takes me a few days. And really, thank you very much for your support and for being here today. Bye, everyone.